How do you know something is P or P hat? And that's a really good question, and people get confused about that all the time. And the bottom line is, you go to your claim. Find the claim. When you find your claim, you find your H naught. Whatever that number is in your claim, that's your P. Right, so my claim is that it's equal to 25%, 0.25. So that's that 0.25, that's going to be the numbers I use in my H naught and my H1. That's your P. Whatever you have in your H naught, H1, and in your claim, same number, that's the P. From the sample, because remember P hat is your sample, or X bar is your sample, find the word sample, or an equivalent for sample. It might be selected, or chosen, or something like that. Then in a survey of, those are all going to be your P hats. There's noise. I'm going to mute that. I don't know. So I'm just muting everybody until I can figure out where the noise is coming from. So that's where you find your P hat, is you find the word sample, and that's where you get the P hat from. So in this word sample, right, includes 540 with 228 of them being yellow. That's where you get your 125, 128 over 540. That's where you get the P hat from. From the word, find the word sample or survey or selected. That's your P hat. That's your sample. But your claim is where you get the P or the mu from. Okay? All right. Good. Moving on. Left-tailed tests. All right, so this is the beginning of Chapter 8B notes. The very first thing on your notes. Let's get someone reading. Ria, can you go ahead and unmute and read this?
The part where it says all.
Yeah, so read this one, read the right side, and then read the left side.
Okay, so H
naught is.
Oh, H naught.
Yep, and then parentheses is like my name is, like Ashley, name colon, and then you write your name, right? So same sort of thing. H naught is, what's H naught? Go ahead.
H naught is mu is equal to mu naught.
Perfect.
And H is.
Sorry.
H1
is.
H1, right? H1 is mu is less than mu
Not. Great.
Okay, so I don't know what that sign is after all.
Alpha. That's a Greek A.
All alpha scale. Then contractor wishes to lower bills less than below decrease.
Right. So these are all the words. So someone asked me earlier, how do I know if it's left-tailed or right-tailed? This is how you know. If your claim involves words like lower, less than, below, decrease, those are all left-tailed words, less than words. So you're going to have your H1 is going to be mu, my mu is less than everybody else's mu. And you're going to have a left-tailed test. So you're going to have your little critical value is going to be right here, and you're going to shade on the left-hand side. Your guilty is going to be on this left side, and this other range over here is going to be the not guilty range. So just again to re-emphasize to you guys, H1 is where you're going to have the stuff happening, where you tell it's left or right-tailed or two-tailed, because H naught is always equals. H naught is always going to be equals. H1 is going to be where it's going to be left-tailed, right-tailed, or two-tailed. So when H1 is less than, that's because your claim was something like lower or below or decrease. And that's going to be a left-tailed test. Ivana, have you read yet? Ivana, can you read the next one?
Yeah.
Thanks.
A or right-tailed test. H naught is mu equals mu naught. H1 is mu greater than mu naught.
Great.
All alpha in the right tail, an additive to increase the life.
Sorry. My bad.
More than and greater.
Right. So again, that's going to be words like increase, more than, greater than, right? These are all going to be words that indicate to you that this is a right tail test when you get those in your claim. That's going to be, you're saying that your mean is greater than, more than everybody else's mean. So you're going to have this symbol here. H1 is going to be that your mean is bigger than everybody else's mean, the standard regular mean. So that means that you're going to have a right tail test, means that you're going to have your critical value right here, and you're going to shade on this right side over here. Sorry, this right side over here. I keep doing that. All right, so again, this will be your guilty area if you get a test stat out this way, and this over here will be your non-guilty. If your test stat, if your sample z-score, its test statistic is in this range, you're going to say, oh, that's, you know, not guilty. And maybe, you know, maybe if it's right here, it sure looks guilty, but you don't have enough evidence to prove it's guilty. So it's not guilty. You would like to make it guilty maybe, but you can't. Maybe you need to take a larger sample size or something to get that z-score higher. All right, and then we have the two-tailed test. Megan, can you read this one?
H naught is mu equal to mu naught. H1 is mu unequal to mu naught.
Mm-hmm.
Alpha is divided equally between the two tails of the critical region. Will the pulse rate remain unchanged? Is equals differ.
Right. So this has these kind of words. Unchanged. Or is equals differs. So when your claim is differs means it's different somehow to the greater than or less than. But also when your claim is that it's equal, then H1 becomes the opposite of your claim. So then that's you'll also get this two-tailed thing there. Those are the situations where you're going to get two tails. When your claim is either H naught, you know, is equals unchanged, or your claim is H is differs, which could be either greater than or less than. So here you're going to have two guilty areas. Anything out here or out here will be guilty, and then this area in the middle will be the non-guilty region. All right. The critical or unusual regions are separated by your critical value. So remember that. These critical values, which you get entirely from your table, your T table, or Z table, Z table being that last row of the T table, you get these critical values from your T table, and they tell you the level, you know, kind of the, where the Z-scores are unusual. So in other words, a Z-score anywhere beyond here or beyond there, those would be the unusual Z-scores. And then this is the same as Chapter 7. These critical values are exactly the same as those from Chapter 7. And remember, your book will call these critical values Z alpha over 2, because that's how they're commonly referred to, but we're just going to call them, in terms of my exams and everything else, we're just going to call them critical value. They mean the same exact thing. So you see Z alpha over 2 in a book, don't get confused and start trying to find Z multiplying by alpha dividing by 2. Just remember, Z alpha over 2 is just the same thing as critical value, and you find it from your table. Okay, let's eliminate that confusion, because that messes a lot of people up, and when I changed that to critical value, people did a lot better. So we're going to leave it like that. Here, again, we're going to not worry about this part here. For a Z distribution, don't sweat it. Just use your, oh, sorry, my bad. Do this one here. Look at it on the T-table using degrees of freedom equals infinity. I wouldn't worry about this other part down here. That I think is just, that confuses folks. You can do it if you want, but people get confused about when to divide by 2 or not divide by 2, and it becomes this whole giant mess. So just use your table, look it up. And then if it's a t-distribution, okay, so first of all, let me ask you this. When do we use a z-distribution? Which situations do I use a z-distribution versus a t-distribution? Anybody remember? Anyone? Anyone?
I don't know the name of the symbol, but it's when something's not known.
Ah, okay, right. So I'm going to make it even simpler than that. I'm going to give you guys this. This is how you know when to use a z-distribution. Easy peasy, or mean Mr. T. So which one of these applies to the z-distribution? Easy peasy or mean Mr. T? Which one? Which one has a z in it?
Easy peasy?
Yep, this one. So that means that T, yeah, proportion, exactly. Proportion, z-table. So you're going to use a z-distribution when you have a proportion. Proportion. And remember, a proportion is when your data is yeses and nos, right? When you're asking a yes/no question. Not what am I asking you, but what the researcher asked the people. Your data was yeses and nos versus your data being numbers. Now let's take a look at this one.
Professor Young?
Yeah.
Just really quick, I just want to make sure we're still on the same page for the critical and rejecting region, right? We haven't gone to the p-values, correct?
Right. We are still on the front page. We're on the first page of 8B. Formulas and definitions 8B. So it's the new packet. It's the new packet, but it's still the first page of that. We have not moved on from there. Okay.
Okay, thank you.
Sure. And then this one again, my question is t-distribution. When do we use the t-distribution? And again, remember easy peasy or mean Mr. T. So this one, which one is this one going to be, guys? Mean Mr. T. Yep. So t-distribution, you're going to use it when you have means. So whenever you have a mean, you're going to use the t-distribution, a t-table. So how do you do that? Look it up in the t-table. And remember, if it's left-tailed, make it negative. If you look at your t-table, I'm going to pull it. I'm not going to be able to take it down when I have it, but that's okay. If you get your t-table, all the numbers on there are all positive. So the thing about it is that you are smart. You know when you have a left-tailed one, and you know all left-tailed z-scores, all z-scores that are less than 0 should be negative on the left side, right? So whenever you you look it up and you find a t-score, if it's or z-score, either one, if it's a left-tailed test, you're going to make it negative. Just make it negative. If it's two-tailed, then you're going to have one positive and one negative. Okay, good deal.
Mrs. Young, is this part of step 1?
This is actually step 2. Well, I haven't given you a step yet, so don't worry about it yet. Don't sweat it.
Okay.
So if it's, for example, here, if you're talking about a two-tailed test, you look it up and you get 2.575, just round it to 2 decimal places, make it positive, negative. I think we can, all right, so this is kind of what I want you guys to do. When you have it, a right-tailed test, you're just going to look it up in the t-table, and you're going to get 2.33. You'll draw your little picture, and if you get 2.33, on the right side, you'll shade the right side. and you're going to put in your critical value. And maybe you even label it critical value. That'd be even better. So that is kind of how you, when you find the critical value, what the steps to do that. Let's not worry about that. All right, so pull out your T-table. It's not on your worksheet. I want you guys to find these amounts here. So I'll put my table out so you guys can find them if you need to. Whoa, smaller. That should be big enough. Okay, so look up and find these three numbers. It's not in your handout. We're still on the first page. Just find them. Okay. So the first one, alpha is 0.05, left-tailed test. Is that one-tailed or two-tailed? Left-tailed. It's one-tailed, alpha is 0.05. So one-tailed, alpha is 0.05. It's going to be right here. And these are z-scores. So we're going to go all the way down to the bottom and just grab the z-score. So it's going to be 1.645. Or you could just put 1.65 if you want to round. Oh, but it's left-tailed, so it should be negative. You guys catch that part? Left-tailed should be negative. Okay, now let's look at the next one. The next one is two-tailed, alpha is 0.05, so two-tailed, so it says two-tailed up here, 0.05, we want this one right there, so we're going to grab this guy right here, 1.960. These are all z-scores. So here I'm going to have positive, it's two-tailed, so it's positive, negative. Positive and negative, 1.96, 0.96, oops. What was that? Okay. And then the last one we're going to look at is alpha is 0.005, but it's right-tailed. So right-tailed again means one-tailed test. So here's the 0.005. You're going to grab that. Z-score is the very bottom one. So these are all proportions. And that one will be 2.576, or you can round it to 2.58. Questions? And you guys good with that part? Is there a hard copy of the table? Yeah, I showed you guys earlier in the notes. Remember, that was my fourth slide. No, that's not it. Canvas. So Canvas, the handouts, and if you go to Canvas, the home, the top module will be the links. The next one is the handouts. They'll have the notes, the quizzes, and the T-table for download. So it's right in there. Your table doesn't have the Z-scores at the end? What? Oh, it does. When it's infinity. Infinity is the Z-scores. So if you go to this T-table, it should have it. Does it not have infinity at the end?
I just found it, and it does have the infinity at the end.
Okay, good. Perfect. Okay, panic. All right. So yeah, so infinity those are z-scores. So if you want, you can just put z. You can put z next to infinity if you want, just to help yourself remember that those are z-scores. totally good with that. That's a good thing to do. Okay, perfect. Now, here is the rest of page 1. These are the steps. So I'll give you guys a minute to start writing them down. These you're going to write down on page 1, on page 13, the front page of your